on the fire ecology aspect. And you are probably familiar with Dr. Richard Hutto and Sue Reel. They are a team in their profession and in their other lives, spouses. And I will just let them introduce themselves and get started.
Okay. I'm at the University of Montana in Biological Sciences and director of the Avian Science Center. It's a center on campus that has as its mission the collection, synthesis, and dissemination of information on Western birds that might help land managers and other decision makers become informed about subjects that birds have opinions on. And so I'm going to show you how that works today. And then Sue and I'll try to go pretty rapidly because this story is very simple, so I can go fast and you're not going to miss anything. And then we'll try to have some time to talk about the kinds of things you can do in the classrooms. We've done things with fire ecology, 3rd grade, 5th grade, middle school, high school. And so there's some resources potentially available if you're interested in this kind of story. So the bird's eye view is really going to be appreciating the importance of severe wildfire. And this is a very different proposition. Okay, there it went. That from what most of us are raised with. If you take a look at this, does it look like these things are rotating at all? I mean, it was supposed to be a slide to just say this is going to change your perception. So the way you view wildfire after 20 minutes will not be the same from the way you perceive it now. Okay, and it's all just listening to the birds. So the first thing I want to talk about is the idea of a fire regime. A regime is basically just the average sorts of kinds of fires that burn in any particular place or vegetation type. Over time, if you just average over many, 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 many years, you get kind of an average situation. And just to make a long story short, the regimes run through a series from very high severity fires that are infrequent, would be sort of the usual kind of fire for some sorts of forest types, to mixed severity where you may have low severity fire come through some years, you may have high severity, or you may have mixture within any fire that burns, down to low severity frequent fires. So some forest types burn relatively frequently, as Ron talked about, and fairly low severity. And so we have these different kinds of fires that burn in different kinds of forests. So how do we know for any particular forest? Can you go ahead and switch when this is, yeah. Or here, maybe if you pass that thing up, it's going to be a lot easier. Here. Okay. So how do we know then, for any particular forest, what the story is and how frequently it burned? Well, one of the ways, as Ron mentioned, is just ask the trees. So here we're going to be using biology today, listening to trees, listening to birds, understanding history. And it's not history back to Native Americans 300-400 years ago. It's history back hundreds of years ago, thousands of years ago. They're carrying an evolutionary message with them. They're carrying information about the past environment within which they evolved. That's where the answers lie, because we as humans, we know, just read Jared Diamond's book on collapse, we tend to muck things up, whether we're talking about us today, Native Americans, whatever. We need to look to evolutionary history to really understand kind of what the system is all about and how all the pieces fit. And so you can go to the tree, and trees often get fire scars.
I can't.
Oh, yeah, you can with your finger. On the pad. Okay, so what happens is, and it's unknown exactly why they scar initially, but a little tree's growing on the ground, probably a little pile of material sitting at the base of the tree, fire burns through, and that little pile of stuff burns fairly intensively right there and injures the tree. The tree goes, ah, God, and so it's got a scar. Once it has a scar, it begins healing over. But now you have a lot of pitch there, and the next time a fire burns through, it really burns that place again, so it scars again. And so the trees begin to carry a signature of past history, so you can cut through that portion of the tree where you have the fire scar, actually count the rings and see when a particular scar occurred. And here's one little scar, then it lives another 5, 6, 7, 8, 9, 10 years, another scar, 5, 6, 7, 8, another scar. You can count the rings and see the intervals between fires. If you play this game for many forest types, in particularly the Southwest, like around Flagstaff, Arizona, this is the picture you get. And here's 1600, here's 2000, here's one line is one particular tree and its signature of when it got scarred. So this tree says, I got burned here in 1623. Then I lived okay until, doggone it, 1654. Got hit again. So you add up the signatures from all the trees in an area, and you begin to see, oh my God, there's fires all over the place. With the average interval being whatever Ron said, 8, 9, 10, 12, 16 years, whatever, pretty frequent. And then around here, 1900, everything's shut off. And so the story is that the usual story goes like this. We probably had low severity fires that burned fairly frequently in these particular forest types where the trees are talking to us. We excluded fire suppression. All the understory starts growing up. It becomes really heavily fueled. Now a fire comes along, the consequence is you get a real huge, unnatural high severity fire. So if you read the Missoulian, that's the story. One little piece that's probably very misleading is it's probably not fire. If this sort of thing really happens, fire exclusion is probably a trivial effect compared to things like timber harvesting and cattle grazing and other things that cause the change in the forest structure such that the understory is much richer than it was in the past. For whatever reason, that kind of story is the one that you see. However, this dramatic tree ring story is probably a bit misleading in that the people that talk about the story tend to extend it to all forests. Maybe even unknowingly. I mean, just in titles in some of the earliest papers, authors probably didn't even kind of know they were doing this in a sense. So historical and anticipated changes in forest ecosystems of the inland west. Well, wait, I thought you just did a study with a little plot down there in New Mexico or Flagstaff or whatever. Now we're talking about the inland west. Here's one, helping western forests heal. The prognosis is poor for U.S. forest ecosystems. Now we're talking about the entire United States. Well, now wait a minute. In fact, if you go to the land fire database here at the Fire Lab and say, what proportion of all the forests fall within the category of the kind of forest that has trees that give these signatures in that particular story? And it's, at the upper end, 15%. More realistically, probably 7, 8, 9%, which means 90% of all forests don't fit that story. So the story we're getting is true for a very small percentage of forest types. Very few outside the window here are going to fit that particular model. The frequency of severe fires that we see burning in most western forest types, and I have to get into a lot of literature, just, I can give you the papers. It's well within the range of variation that's natural out there. So when you see a severe fire burning for many forest types, like 80% or more, that's normal. They're the mixed severity and the high severity fire regimes as most of the forest types that we see here in the Northern Rockies. So if we go back to our fire regimes, from high severity infrequent fires to low severity infrequent to frequent, the story is really more accurately something like this. There's been a dramatic change in the fire regimes in these particular forest types, which are a minority. If you go toward the mixed severity and the high severity, there's very little evidence that there's any change whatsoever in the kinds of fires that are burning in those particular forests. And this is a long story, a lot of literature, a lot of controversy. I'm just standing on the edge, giving you that perspective, and you'll have to read these things yourself. So if that's the real story, we've been taught that we're down in this area where it's very infrequent fire, very low severity, frequent fire, low severity. So when something like this burns, what do? And here is one of those right outside the window right here, 5 miles away, Black Mountain. As soon as this burns, you open the Missoulian, and the words you see associated with that fire are horror, disaster, devastation, destruction, crime, scar. Those are the typical adjectives that go with fires that burn around here. Even Yellowstone, you couldn't get a forest type that better fits that infrequent high-severity fire regime. Even there, the words that the press used when Yellowstone burned was horror, devastation, destruction. There were calls for the resignation of the superintendent of the park, the Secretary of Interior. I don't know who all was about to lose their job. It was somebody's fault that that happened. But if you go back, again, historically, it's not at all unnatural. It's exactly the kinds of fires that frequented that sort of vegetation type forever. Now, what's interesting, the negative perception of severe fire is a problem, because the kinds of fires that create significant ecological change are just those kinds of fires. The major, severe, intense, devastating, horrible, wasteful, catastrophic crown fires are the magic, biologically. And that's what the birds are telling us. And that's what I'm going to tell you about. If this kind of forest and this kind of aftermath is natural, there ought to be plants and animals that are telling us that. There ought to be things that have evolved to depend on that. And so we're going to ask that question. And we're going to use birds as a tool and say, hey, birds, are there any of you that kind of look at this sort of situation as being kind of neat? And why you use birds is that they're a great tool for monitoring ecological effects, because they sing to you, they tell you they're there, they tell you their name. You don't even have to have equipment. You just stand out there and they go, you know, oh, flycatcher. Oh, crow, you know, and you just make out your list, and there's no other group of organisms that identifies themselves for you when you walk out to do a survey. Birds. And so if you do this, oh, here's a, so there is, well, it's an olive-sided flycatcher, right? Come on, everyone knows this. Outside your window, what is it? Pine siskin. How about that one? It's a junco. Oh. Robin. Everyone knows robin. Yeah, it's a flicker. You see what I mean? I can be blindfolded and get data that are amazing. Within 10 minutes, I can tell you everything within a football field around me, get the heck out of there and go to another point and get another database, another bit of data, another bit of data. So we've done this all throughout northern Idaho and Montana. We now have 40,000 points scattered throughout the area. We know what occurs where. And what's amazing, if you go into one of those burned up forests, as Sue and I did after 1988, when we got some money from National Geographic to start looking at this, we just asked ourselves, I wonder what's in these forests, because no one had really poked around like that. This is only 15, 20 years ago. We had 2 pages full of names over about 100 species that we detected in these burned forests. Huge. I mean, that alone is amazing. That's a lesson for any level, 3rd grade, 5th grade, middle school. You get over 100 species if you walk into one of those forests and look. Some of you might say, oh, now you're going to try to tell us those burned forests are great, cool things. I can see 100 species standing on the Wilma building downtown. It doesn't mean the Wilma buildings. And we go, yeah. But I can assure you, over 50% of those are living in there, nesting in there. We find nests of at least 50% of those. So a very large number are in those forests. They're not just passing over. They're in there, and they're using it. What's even more amazing is if you tally up how often a species occurs in a particular vegetation type. I don't know if you can read these. These are different vegetation types: burns, clear cuts, thin forest, spruce fir, mixed conifer, aspen, riparian, sagebrush, grassland. And you just go to the library and go read any journal that has a list of the birds that someone studied. And you have at least 30 to 50 studies in each of these types, and then say, what proportion of those studies said this bird is there? Robin is, 60% of the times you'll see them in just about any vegetation type except grasslands. But nowhere are they more abundant than in burned forest. Over 95% of the studies that have ever been done in burned forest say robins are there. I mean, robins are about fire. Yeah, they're about a lot of other stuff too. But that's pretty neat. And what's even more amazing is you can find other species, and here's the most extreme one, black-backed woodpecker, where they're in over 80 or 85% of all the studies ever been published in burned forest that happen to have bird lists. But you can't even find them anywhere else, basically. And so we published this stuff in '95. Did that work? Okay, that's all right. Go back one, or let's see. Is that just up arrow? Up arrow? No, back again. No, you're going forward. There, now down. Okay. So some people were saying, oh my gosh, he's using the literature and there's lots of different studies in different ways and blah, blah, blah. They're missing data. There's birds. Those blackbacks are all over the place. They're just sort of rare in some types. And so we said, all right, we need to be systematic and get data where we're doing exactly the same method through every conceivable vegetation type. And so we've done that. Here's points that we've done in northern Idaho, throughout Montana. As I said, there's about 40,000 of these everywhere. We've been in parking lots, shopping marts. We know what birds occur in what cover type. And here's what you get when you do that and get out of the literature-based survey and just do real data. And here's the number of hundreds or thousands of points in each of these kind of vegetation types. Now it's a little broader categories. And the same result jumps out. This blackback, I'm telling you, is relatively restricted to burned up forests. And the more, it's taken me 20 years, I'm only giving you 20 minutes, it's taken me 20 years to begin to appreciate the significance of this. It's huge. This bird is talking to us, and all we have to do is listen. If you go into burned forests, so here in 2003, we had a lot of fires in western Montana. We went into 18 of these and said, okay, we're convinced that blackback woodpeckers occur primarily in burned up forests. But where in those burned forests do they occur? So we put, points randomly distributed throughout the fires in areas that are fairly green and in areas that are sort of brown needled and areas that are fairly black. And so you get a field crew, bunch of hotshot birder types, and you train them. You train them to record the severity of the fire around the survey point from green to green, brown, 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 black, black. And this corresponds very well with the severity maps that the Forest Service, for example, would use. And be darned if here are what the data show. The probability of seeing one of these goes up, 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 up when you get to the more severely burned conditions. So even within a fire, if it's not severely burned, you don't have as good a chance of seeing it. Well, now this is interesting. Because if natural fires are all low severity, frequent, that doesn't make sense. This thing is telling us that probably naturally, over thousands of years, very severe conditions are part of the story. And it's part of what we have to learn to live with. There's disastrous parts of that. We lose lives, we lose our property. But I'm sorry, it's a natural part of the system had to have disturbance, and severe disturbance, whether it's tornadoes, whether it's hurricanes, whether it's fire, whether it's floods. And there's going to be plants and animals that have evolved to depend on those severe events. So some people would say, oh, now I doubt your data because you just missed all the birds in the more green forests. If you go into the more severe forests, they're easier to detect. So you go, oh God, give me a break. Okay, we'll do playbacks. You can go down here. Is that going to work? No, it's not going to work because I didn't move the song over. You can do a playback of a blackback drumming, and they get real pissed off because they think another bird's in their territory and they come in to get it. So you can bring them out if they're in there and do those kinds of surveys. And here's the results from playback experiments, and it's even more dramatic than not using playbacks. I mean, these guys like it hot. So I published a paper in Ecology called Some Like It Hot. And this has been known for a long time. It's just, like I said, it's taken me 20 years to begin to get a grip. So it's understandable that we haven't appreciated this as a public at large. In reference to blackbacks, Manly Hardy wrote Major Bendire in 1895, specimens are so abundant in fire-killed timber areas, I once shot the heads off of 6 when I was short of material for stew. So people are writing about this 100 years. They knew there's a lot of blackbacks in these burned up forests. Now, everything just begins to make sense. Look at a blackback woodpecker against that tree. And tell me that's not any more interesting or significant as a white-tailed ptarmigan in a white background of snow. Tell me natural selection and evolution hasn't led to that particular coloration in this particular environment and that particular coloration in this particular environment. Everything about this bird screams fire, severe fire. What are they doing? They go in to get beetle larvae. So if you think the blackback story is cool, it's much more cool when you get into insect ecology. There are beetles that can detect the heat with infrared sensors on their thorax for up to 100 miles away, as articles in Science were published. You get these beetles in the genus Melanophila, black lovers, that zoom into these fires, lay their eggs as the timber's still smoldering, basically. And why? Because the trees are now defenseless. They're dead. There's charcoal bark on the outside, but the wood underneath is great. And so the beetles are in there laying eggs so their larvae can eat that great wood and grow up and have another generation and do it all again. Well, the woodpeckers come in to get those larvae. Here's the infrared detector on the side of the thorax, blown up. Here's a little beetle. And this has been written about. In 1943, there was an article where a fellow wrote about football games in Berkeley Memorial Stadium, saying, you know, at the time, in 1940s, there'd be like 50,000 cigarettes lit at once. And these beetles would come in because of the smoke, the haze, and it would annoy the patrons more than a Stanford touchdown. And then in the last few years, there's been an article in Science talking about the significance of longhorns for some of the longhorn bees. What are these things for? And it turns out those little longhorns are smoke detectors. They can detect tiny, tiny concentrations of smoke in the air. So you have a whole host of critters that have evolved to respond to smoke and fire and heat and all that kind of stuff. So there's just cool biology going on. So the first year after fire, you begin to see evidence that woodpeckers have come in. All the trees become riddled like this, where they've dug into, flick the bark away to get in there to get the beetle larvae. If you haven't seen them, I wonder if this works. Doesn't, forget it. I have a video clip to show you, and I'll show you how you can look at some of that later. That's kind of. So this is a poster child for the story, blackback woodpecker. And I shouldn't ignore the fact that it's not just the blackback. There's lots of other species that are pretty cool, just not as dramatic. Here's a three-toed woodpecker, closely related. Here are the data for it on where it occurs. Look at that. You know, it's at least twice as common in fire as anywhere else. There's the three-toed, same thing, hotter, better. Hairy woodpecker. Hairy woodpecker. It's at your feeder. It's probably right outside the window there. Yeah, they are, but nowhere are they more abundant than in burned forests, post-fire. And they get hot. Hotter, the better. Flickers, same thing. Bluebirds, you got Bluebird Society, bluebird lovers. They think, well, gee, we better put up boxes to save the bluebird population. Well, wait a minute. What do they naturally use? Fire. Nowhere are they more abundant than burned up forests. If you want to see a mountain bluebird, that's where you go. If you don't see them on a fence. And this is more dramatic than the blackback. It's got to be toast before these things show. So this is a story about lots of things. And what I've tried to do here, that's it, in 20 minutes, is change your perspective on severe fire. I think the bottom line is, this is a critter that's just talking to us as an indicator of something big. It's not about blackbacks. Who cares about blackbacks? This is not about conserving some bird. It's about being intelligent enough to listen to this bird that is indicating something that we need to listen to learn about. It's saying this environment right here is the environmental backdrop against which I evolved and with which I'm going to require to be successful. So the implication is huge. It's not that many organisms are able to survive fire. It's that they may require fire in order to survive. So, let's see. We could talk, there's obvious management implications that come after this. And I have some slides showing that. It's kind of cool to think about some of this stuff, but okay, so I'll try to rip through that pretty fast. But I mean, just think about it. What is to yourselves? What does this mean? What does this mean? When a fire burns up, now, given this story, what should we be doing? We should be downtown Missoula dancing in the street. We aren't. We're closer than any other city in the United States of America to being there. And that's only through education that we'll get there. You're the ones who are going to be responsible for changing the system to the point where we begin to celebrate severe fire events. We don't, though. Why? Because right off of the bottle, we're trained to think something else. This shameful waste weakens America. This is what we get. This is what's out there. Smokey Bear comic book, which you can still get. This is the original Smokey Bear comic book. As Smokey grew up, he had something to tell folks, and he still tells them the same thing. He tells them how he hates forest fires, how they destroy his animal friends, how they're used to burn up timber that could have been used to make a home, perhaps a home for you. How they waste wood that could have gone into furniture, or even to make paper to put comic books on. You say, oh, come on, that's the 40s. We've grown up. Yeah, well, here's a sign on 3rd Street just 2 years ago. Unfortunately, they can't run for their lives, the trees. This is bad for them. Oh, wait, if you ask a biologist, fire is the thing they need in order to be successful in their reproduction. Or as Much, who's back there, wrote this cool article back in 1970, about 1970, about how plants may actually have evolved characteristics that enhance the probability that there is a fire. They need it. They want it. They love it. That's a different message than this one. If you go on the Smokey Bear webpage, good fires, prescribed. Bad fires, wildfire. If you look at the Missoulian after a fire, which I do because it's entertaining, of course. You know, there was an article in New Yorker some years ago about the Missoulian and how it's so fun to read the letters of the editor of the Missoulian. Yeah, here we are in the New Yorker because it's so entertaining. So this is like after the fires of 2000 in the Bitterroot, 13 October 01. The people who say all fires are good for the forest are totally disregarding catastrophic fires, which burn so hot and deep that the ground is sterile and will not rejuvenate for decades. These are the folks using junk science, that's me, that we're supposed to embrace. The burn snags left standing are in no way good or healthy. Well, I'm sorry, you're wrong. You're wrong. They are good, they are healthy, they are the very thing that those critters need that I just showed you on the graph. So when something like this happens, because we've been trained to think that other way, what do? Well, it's useless otherwise. Let's take the wood out at least. Let's at least get some value out of it. That's salvage. Let's salvage some value. And so like a knee-jerk, 89.5% who were surveyed in the Bitterroot after the fire say it's important to salvage that timber. We as human beings do not agree on anything to the tune of 89.5%, except for one. You know, a landslide in the presidential election is 52%. We're talking 90% of us agree on one thing, and that's we better get in there and get this stuff after it burns. go, well, wait, isn't that the stuff that these things need? And the answer is yes. It is a trade-off. When you do this, and you collect data and go out and ask the birds, are you there? The data are very clear. Your salvage log, dark lines, unlogged, higher lines. If you don't salvage log, there's always more critters. And in most cases, this is all the timber drillers here, they totally disappear. You can't go in and harvest timber and have these sorts of wildlife species that depend on the aftermath. It's not the fire they like. Nobody likes fire, you're gonna die. They like the aftermath. I mean, even on MSNBC, here's somebody getting brownie points because they used timber harvested for following a forest fire in New Mexico. So they got an environmental stamp of approval because they used that wood. My comment is, we have got plenty of wood in the forest. The last place we should be going is in bird. A last place. But yet, there will be environmental, there's always legislation that gets passed in the fire burns to expedite salvage without environmental. It's the last place we should be going. There's plenty of wood out there to harvest in the interface, the urban interface. So that's the story. Lots of critters, morel mushrooms all the way around to the birds and frogs and other things. This boreal toad's a really cool story. Need fire. Okay. Oh, well, I can yell really loud. So that's kind of it, and I think I just want you to get this perspective that a fire like this can be a beautiful thing as opposed to a scar. And one thing we've done is put together a series of slides from within burned up forest, just to sort of show you firsthand what it's like to walk out in one of those, if you don't get a chance to go out with Sue and myself. And so, yeah, could you go on to...
Take it out?
Yeah, just close that one down. Oh, here, I can do that here.
Yeah.
Here, to see if this works. So here's a slideshow. So I wrote to this guy, Mark Cohn, and said, can I use your music on a slideshow? He thought this guy's crazy on a fire thing, but let me do it anyway. So all these pictures have been burned, severely burned for us. That's good, that's all it's going to do.
How many dreams you've chased across sand and sky and grass, looking for one safe place, yeah, yeah, one safe place, yeah, yeah. Will you make a smooth landing? Will you break your fall from grace into the arms of understanding, looking for one safe place, yeah, yeah, one safe place, yeah. Oh, life is tried by fire, and love's the sweetest taste. And I pray it lifts us higher to one safe place, yeah, hey, yeah, one safe place, yeah. One safe place, yeah, yeah. How many roads we've tried, how many dreams we've chased, across sand and sky and ground. We're looking for one safe place, yeah. Hey, yeah. One safe place, yeah. Hey.
Oh, that's too bad. Well, the next picture just shows a totally clear-cut kind of, I don't know. Don't worry about it. So you can get a lot of this material online. So if you close those down and maybe go online, honey, just X those out. If you can go to the, yeah, just go there and just type in Avian Science Center, see if, so if you just type in Avian Science Center, and then Sue will tell you about some other stuff. Just go to the live search. There you go. There you go. Okay.
What's been going on with
So,
Please, Scott.
so on Avian Science Center, for example, if you want, okay, now here's the portraits in black video. So it's there. You can look at it. There's another video that was showing here on with a CD that's available online. You type in the word disturbance. Really nice. 19 minutes. Award-winning Masters of Fine Arts at Bozeman. He made this film with, I've narrated part of it, giving this story, and it's mixed with Forest Service folks from the Bitterroot, talking about the trade-offs of, you know, how do we live with fire, protect ourselves and our property, while at the same time think about things like blackback woodpeckers. So that's kind of that story, disturbance. Then you can go, so if you just go under projects, Fire Ecology. Fire Ecology. So here is a presentation. So here's a slideshow, like, you know, close to this one. And I have the words written below so you kind of know what goes with the particular slide. That's probably good enough. 2007. I may try to update it because things are happening all the time with new, interesting information. But most of those slides that I showed you are in that slideshow. So if you want a PowerPoint. And then here's the video, Jeremy Roberts. Here's video Jeremy Roberts produced Disturbance. And I don't know. I don't know. Yeah, click here to see the video trailer. Video trailer. You should be able to get the whole thing. Yeah, Conservation Media. That's where it is.
On his website.
Yeah. No. Yeah. Disturbance trailer. Yeah, you can get the whole thing. This is just a trailer. But you can get the whole thing in HD, so it shows on a screen really nice.
We can show that at lunch again if you'd like to see it.
Yeah, the thing is, it's 19 minutes. You really need to just sit and listen at your house and, you know, alone to get to appreciate the job that he did. And then Sue can talk about other aspects we've done. It's just going into burned forest is fantastic for art, writing, and biology. Science, math, and math. I mean, you can do anything out in these burned forests. It's just a way to really get into some topics that you might want to.
So one of the things that I've been helping Dick do research. Oh, well, okay.
Yeah, it's going to be back and forth.
Yeah.
Here, hold that.
All right.
Just hold it, maybe.
Okay.
Wait a second.
Technology. I wish we were out in the woods. You can hook me up while I talk. One of the things that have been fun for us is because of Dick's research. I get to use Dick out in the field and help develop some curriculum. And you've got a couple of things. One of our best opportunities is when we had the Black Mountain Fire, which is actually at Blue Mountain, Black and Blue. Out west of here, I think it was 2007, we had that fire that was frightening for Missoula, for sure. But it became a wonderful classroom for us, and we did years. That was No, not 2003, I believe. So it's a 7-year-old fire now. It's getting a little old. I mean, it's not as exciting as the first few years, because you can see severe fire is like an avalanche or a hurricane. It sets back the ecological community to zero. So it's dramatic when it starts to regrow. It's really, it's really fun to get a classroom out there. If you at all possible find a fire in your area, I would recommend you contact your Forest Service, call your local district and say, is there any fire I can visit with my classroom? And they will probably help you do that. But that's what we had. We had this severe fire, and it's always in the summer. But by that following spring, you can see dramatic changes on the landscape, especially in these severe fires, because everything's gone. But then you start watching the blades of grass, and from there, the next couple of years, it's just a dynamic, exciting community to take your classroom and talk about forest succession, the ecology of species, and the way they've been changed. Certainly you lose some species of animals and plants, but you get a tremendous regrowth of all of these wonderful plants and animals. And it's really exciting. It's one of my favorite communities to take classrooms to, because it's just, it's wild and dramatic. And so what we've done is we've got actually up at Blue Mountain, about a couple of miles up the Blue Mountain Road, there's a little nature trail that burned over in the Black Mountain Fire. So this fire story is the 20 sites along a nature trail, and basically it features all the things that Dick was talking about, all the plants and animals adapted to fire, from ponderosa pine to little beetles, and certainly all the birds.
I would just emphasize, it's not, because I get so sensitive to these words now, it's not just regrowth, which is kind of the way we like to teach. Oh, don't worry, everything's coming back. That's not the point. The point is we get new stuff that comes in that wouldn't be there without that part. Yeah, you're going to get an old tree in 700 years. Wait 700 years, that's what it takes. But if you don't have that disturbance, you don't have half of all the diversity of life on Earth. Depends on disturbance creating different stages of succession. And so you have to get excited about the new things that happen after, not worry so much you're going to get restored back to what it was, as if that's what ought to be. Well, if you're a black-backed woodpecker, that's what ought to be. A 1-year-old burn, not a 700-year-old forest. So it's a perspective thing. You need to change your perspective. And the other thing was
So there's...
Oh, yeah, it's only a narrow window, 5 years or less.
Yeah, it's a short window.
The exciting stuff, sure, neat things happen 10 years after, 20 years after, 30 years. But if you want the woodpecker story, it's the first few years after fire, and then things die off. And by 10 years after going up Patty Canyon, we had a harder time finding woodpeckers to show people. But Patty Canyon was another gold mine for educators. They said, we were so lucky. In our lifetime, we're not going to have another Black Mountain 5 miles from town. Right. We're so lucky to have had that event.
And it's not just the birds. I mean, there's some tremendous, neat plant ecology going on there with seeds that are in the seed bank that have to wait maybe 100 years for a fire to come through so that they can actually germinate. That's ceanothus or skunk brush. So there's just this tremendous wealth of neat stories out there. And then the other thing, I've worked mostly with younger students up to the middle school, and basically just exploring the environment. But there's so many neat ecological stories. But it also is it's also interesting to bring in the human perspective and human activities, and debate the issue of can we live with fire in the landscape, and who's involved. And so there's all kinds of ways you can develop curriculum or use existing curriculum. And this afternoon you're going to meet with Jane Kempler-Smith, has this wonderful fire trunk. Has anybody heard of the fire trunk out at the fire lab or used it? Well, be sure that, have you used it? It's a fantastic trunk full of curriculum. And it's pretty much up to the middle schools that will expose kids to all kinds of neat stories about fire.
It's mostly physical effect stuff, but it's...
Yeah, it has some fire ecology though also. And then one of the things that we had the opportunity to do with the Black Mountain Fire is Big Sky High School had a biology teacher, Dave Oberbillig, that was very interested in using that as a classroom. So they, the problem with the high schools is they don't get a lot of time out because of their schedule. But he was able in an hour and a half, they had block, he was able to get out within an hour and a half up to Black Mountain and come back. But the Avian Science Center, Dick and his staff helped Dave develop some surveys of the vegetation and the birds, and I believe maybe the beetles, bird use, or bug use on the trees. And so they actually were collecting data, analyzing data, trying to basically do science, posing a question. And
Doing histograms.
yeah.
Yeah, you can find fun.
So it was really fun to get those high school kids out there. So my whole goal with I'm a wildlife educator for the Lolo National Forest, by the way. My office is right next door, and my whole goal is to get kids on the landscape. It's getting kids outside. I'll do classroom programming, but I think the real change, the real educational change is when you get kids in the field, they get dirty, it rains, it snows. This is a black, dark, dirty experience, but I think they really enjoy it a lot. So if you are interested in going out in the field, let me know. Maybe I can help find ways, depending on where you live, to get you to a recent fire. Unfortunately, it hasn't been a very good fire year. It's been pretty quiet this year.
From our perspective.
Yeah, we're good fire year.
Otherwise.
So, is there any questions? No questions.
I have a question on this.
Yeah.
Exactly is this trail?
So the trail is, if you know where Blue Mountain is, the Blue Mountain Road that goes all the way up to the fire lookout, which is right, it's a mile due, 2 miles due west.
Near my
So,
play flat.
so as you travel up the Blue Mountain Road, not the asphalt road, but the actual dirt road, you just go up. Milepost 2. It's only 2 miles up, and it's the first trail after the Fall Golf Course, if you know that area.
But it's more dramatic looking at milepost 4. The trail's at 2, but that was the edge of the fire, the very end, where it was finally went out. So it's not as, now 7 years later or whatever, it's not quite as dramatic as if you go to milepost 4, where there was some severe stuff, where you can get the whole mix of everything from green trees to black.
But if you're in the Bitterroot, we just had a couple of fires. Downing Mountain right outside of Hamilton. If you're anywhere near Hamilton, that's close. So.
I've had Larry Weeks with the National Audubon Society for the last, I don't know, I think 6 or 7 years we've gone up to black. But the last few years we've been going to the black cat.
Oh, good.
And the same things. And I teach 3rd grade, and he comes in and teaches 3 days before we go out, and we talk about the hidden treasures under the ground, and so there's all kinds of things that they look for when we're out there. It's a wonderful.
It's a great field trip, isn't it?
The most recent one close by is about Frenchtown, the black.
That's what she said.
Black cat.
Yeah.
Black cat. I was thinking Sealy.
Yeah, no, black cat. But it's also getting to the point where
Right. It's getting old. We need a new fire.
we need.
Let's go.
Let's go. Also, in The Naturalist, a couple of years ago, there was a really nice write-up about visiting the Black Mountain Fire. The Montana Natural History Center has an exhibit about the benefits of fire to plants and animals, too, a good wall exhibit. Yeah, they have the whole wall with it. So there's materials out there that you can use if you need. Okay. We should probably keep moving.
Yeah, thank you very, very much.